All right, I think with 5 minutes after the hour, we should get started. Hopefully some more people join in. But first of all, hello and welcome to the 26th Annual Popsicle Stick Bridge Competition hosted by ASCE's Younger Member Forum and our Seattle section. We want to do a quick thank you to some of our sponsors. As you see up here, keep going. Sorry, there you go. Um, so just a couple quick notes. This meeting is being recorded. So we ask you all to please stay muted if you're not speaking. Feel free to raise your hand and ask questions in the chat. We'll also have some trivia questions as we go on, and we're going to ask that you guys answer through the chat. It's going to be on a first to type basis on who wins the trivia, and that'll come periodically. And there is a prize to be won, so jump in on that. And please also have your camera ready. We're gonna take a group screenshot in kind of gallery mode right before we start crushing all the bridges. So please get prepped for that. And we just thank you. So excited to get started. Let's dig in. So doing a quick overview of how the morning's gonna go. We're doing some morning announcements. We're gonna go over just kind of a brief overview of what the American Society of Civil Engineers is and what it means to be a civil engineer. We're gonna talk about some of the events and opportunities that the YMF offers through K-12 and also the scholarship opportunities. Like I said, we're gonna play some trivia. It's going to be kind of sporadic throughout the day, so stay tuned. We're going to go over the competition rules, what you guys all had to do to compete, and then we're going to break some bridges. So we're really excited. We also have a couple guest speakers here today, so thank you for joining. And then we're going to jump into the awards. So to start off, I'm one of your co-hosts. I'm Mackenzie Capassi. I work for Kennedy Jenks Consultants. I'm a wastewater treatment designer and planner. My co-host.
Good morning, everyone. I'm Romulus Regudos Jr. I'm a geotechnical engineer at PNGeo. I went to the University of Washington, graduated with my bachelor's and master's degree.
Oh, I totally forgot to say that stuff. I went to Arizona State University. I graduated with a bachelor's and master's in civil engineering and then environmental and sustainable engineering. And I am the current president-elect for the YMF, and Romulus is our past executive. So this is our Popsicle Stick Bridge team. Lisa, would you like to introduce your team?
Good morning, everyone. So yes, Amy and I were the PSB co-chairs this year, and so we are putting on this event. We've been planning throughout the year, and we had a lot of help from Kelvin, who's also on today, and he helped get our swag, those nice masks that we got out to all of you, and then we also had Ken Sullivan, who helped with getting school contacts. And so I work at KPFF, and then Amy works at Flatiron Construction, and we both graduated from UW, so go Dogs.
So we're going to do a quick round of applause. Thank you, everybody. Virtual round of applause. I don't know if it's Snap or something, but we just really appreciate all the hard work that this team put into getting this all ready for us. And we hope all the student participants had a fun time, even though it's slightly different circumstances this year. We still appreciate our team working hard and all the students who participated.
So before we get started, I just want to ask a question to everyone out there in the virtual world. What do y'all think a civil engineer does? So just feel free to type in the chat. We'll wait about 15 seconds. So we have one response from Lola. They think a civil engineer builds and engineers things for society, and that is 100% correct. So a civil engineer, the best way I like to describe it is when you wake up in the morning, you brush your teeth, you have fresh water. When you're driving around, going to the mall or road tripping, the nice roads you're on and the bridges you pass over, or when you go to school, hopefully again soon, in the structure you're in, a civil engineer plays a vital role in creating that type of infrastructure you guys use each and every day. And these are some of my friends and colleagues who are also civil engineers. And here's just a quick slide on some of the several disciplines we do have in civil engineering. As you can see, we're a very diverse field of engineering. I myself, being a geotechnical engineer, I deal with soil engineering, such as slope stability issues or liquefaction potential issues, earthquake engineering, all fun things like that. I mean, probably the most well-known for us is probably structural engineering, transportation, construction, and we also
Water.
have water, Mackenzie, the water resource. We have environmental and sustainability and many, many more. So we're a very diverse field. So if this is something you're interested in pursuing, it's one of the more fun engineering disciplines to get into.
As the Lion King said, everything the light touches is our kingdom. And underground. So we just added some photos of what a civil engineer is. So this is me and our current president, Bobby. We were witnessing some pipe ramming this week. It was really exciting. It's a wastewater plant that my firm helped design in San Francisco. And this is a photo of ASCE participants at the Panama Canal construction of the next set of locks, which happened 5 years ago or so.
And here are a couple projects. Here on the left is Taipei 101, which was once the tallest structure around the world. On the top right, that is the tunnel boring machine known as Bertha here locally that drilled the local SR-99 tunnel. And I think at the time of construction, it was the largest diameter bored tunnel in the world. And here and down bottom right corner is a excavation I was working on in Kirkland. That's about 20 feet below the existing ground surface. So a lot of fun stuff. So real quickly, us as the American Society of Civil Engineers, we're a engineering society comprised of over 150,000 members across the world. We work on the design manuals that are used in practice. In addition, we also do a lot of community outreach. As we mentioned, we do K through 12 outreach, university outreach, community service, and professional development for our members.
So the big thing in the news this week is America's Infrastructure Report Card. So you may or may not have heard of this before, but every few years or so, the American Society of Civil Engineers rates our infrastructure and everything from, you kind of see on the slide here, we do aviation, bridges, wastewater, stormwater, our transportation system, literally everything you can think of that involves civil engineering and our built environment gets a score, and we use that to help generate our risk and our reliability with our systems, where we need to go for improvement, how can we get additional funding, and work going out there so that we can make sure that our infrastructure is not only usable but safe. So this year, as of Wednesday, the report came out and America's infrastructure got a C-, which doesn't sound very good, but it's actually the first time in 20 years that our grade has scored above a D. So it's actually pretty exciting, but we still have, this is a major success, and it's a testament to the strength of our industry, but we still have a really long way to go to ensure that our country's infrastructure is reliable and sustainable. So the overall country gets a grade, but we also break it down by state. So back in 2019, we had our Washington report card, and actually several of our ASCE YMF and now section members co-authored the state report. So it's really exciting. Ram, my co-host, is actually one of them that helped to grade our great state. And we got a C. So we are slightly above the national average. But again, yeah, still have a long way to go. So we need new great engineers like all of our student participants to join the industry and help, improve our infrastructure. So I want to give a shout out to the ASCE movie that got produced. I don't know if you all have seen it yet. If you haven't, you should. It's awesome. You can stream it on Netflix. It is a movie that just depicts what we do as engineers, goes into some really cool projects from around the world, and it just shows a kind of cool side of the engineering world that you don't really get to see until you're in it. It just, it's just a real good true grit kind of movie. So give it a watch. It's not too terribly long. I think it's only like 45 minutes. So it's great.
So as I mentioned before, we do a lot of K through 12 outreach. We do go to classrooms, talk about what we do as engineers. We also have some interactive classroom activities. So if that's something you would be interested in doing, just contact us there at the QR code. Also, we started a hashtag Ask an Engineer campaign. So we do have a section on our website devoted to you all being able to ask us questions and respond back with cool videos about what it's like to be a civil engineer.
We will flash this again if you don't have time to pull up your QR code that quick.
Additionally, we also provide scholarships to graduate high school seniors pursuing a field in STEM. We award scholarships up to $1,000. Last year we gave $3,000 away, and we're looking to give away more this year. So if you're interested in applying, please follow that QR code there, which we'll also have available again later in this presentation.
All right, so we're gonna do a quick round of trivia. So everyone get your chat boxes open and ready to respond. Ram, you're gonna have to read off the winners because with me sharing the screen, I cannot see the chat. So
sure.
Here we go. We're gonna break them up into like 3 chunks. So there'll be 3 questions and then we'll do another 3 chunks a little later. So the most correct answer at the end will win. So if you don't, if no one gets it right, we'll still get you points. All right, so first question, what is the most commonly used building material? Should have set like a time, or like the Jeopardy music sound.
Iron, steel, there we go. Concrete.
Woohoo!
That is correct.
Concrete is the second most consumed substance in the entire world, behind water. Globally, we use approximately 10 billion tons of concrete each year, which is insane. But concrete's great, and I love it. All right, second question. What is the name of this building? Should have done some Jeopardy backing music.
So we got New York something. All right, we're in the right city. That's good. Empire State. It's nearby, but not quite. That'll actually show up later in the presentation for a little hint or for trivia.
More hints. It is 1,046 feet tall. Clearly that would help you with the name of it.
Named after our car brand. Oh, there we go.
Yay!
The Chrysler Building.
Yay. So the Chrysler Building is 1,046 feet tall and located in New York. It has 77 floors, and it is famous for some of its gargoyles at the top, which you can kind of see hanging off the corners right before all the silver starts. Oh, I lied. Not breaking it up into 3. 2 for that time. Yeah, I had another slide in there. But we wanted to take a moment to pause to thank all of our generous sponsors. We had amazing sponsors this year, and we could not have gone through this with that the events the generous could not have done the event today without the generous sponsors. So thank you to all these DCI Engineering, Kennedy Jenks, Shannon Wilson, Conda Johnson and Associates, by Conan Carter Quinn, personal donation by Elliot Kim, Seattle Public Utilities for helping us crush the bridges, SCF, Structural Engineering Foundation, Underground Printing, and the Museum of Flight. Thank you, everyone. Thank you to our sponsors. It's so greatly appreciated. Virtual class.
So real quickly, just want to recognize the schools that are participating this year. We have Harrison Prep, Ingram High School, O'Day High School, Shoreline Christian, and Sherwood High School. Thank you so much for participating this year. We really appreciate it. And before we go on to Breaking Bridges, we'll take a quick picture right now. So if you can please turn on your cameras and I'll take a quick picture.
Mackenzie, do you want to stop sharing so we can get the gallery view?
Yes, I do. How do I do that? It just gives me the option to new share. There we go. Got it. Sorry. I don't use Zoom. Lisa, are you going to take the photo or who should take the photo?
Yes, I can take the photo. All right. Everyone got their cameras on? Get 5 seconds to adjust. All right. 3, 2, 1. Okay, I took the photo, so.
All right. All right, got my screen back? Yes, okay. All right, so I'm gonna go into, hand it back over to Lisa. Talk about the competition building code.
Yeah, so as you all know, we had a competition building code, and so these are all the rules for this year. I won't go into it a lot, but we wanted to keep, one of the big changes was the bridges had to be 300 grams or less, so we saw a lot of innovation this year and a lot of efficient bridges that were under 300 grams but could still take a lot of weight, and so good job, you guys. But yeah, so just to go over technical judging, if you were outside of these rules, we took off some points, so yeah.
All right, let's break some bridges. So first up, we have the Matthew McDonald Memorial Bridge from Harris Prep. The bridge weighed 222.1 grams, and there was an estimated load that it could handle of 10 pounds. So here is Lola's bridge. It looks pretty awesome. And let's dive into it. Oh,
McDonald Memorial Bridge, which is
hang on, I'm going to start that over.
Hi, I'm Lola Stevens, and my bridge is the Matthew McDonald Memorial Bridge, which is named after a bridge building partner of mine that moved to a different state. First thing that I did for my bridge was just kind of build a rough draft and experiment. So we did several experiments, and some of the things that we found were that sanded popsicle sticks stuck together much better than unsanded popsicle sticks. I planned to use that in my final bridge design, but I didn't end up doing that because the way the design is the popsicle sticks only touched really on the tips, so it wasn't really necessary to sand. I started running out of time for my first rough draft bridge, so I decided to just test my roadway because I was pretty confident with my roadway design and I wanted to see how it did to see if I should incorporate that into my final design. I tested it, and it actually was pretty good and held a lot. It barely broke at all. I started to plan out my final bridge, and I took some graph paper and I started tracing the popsicle sticks and figuring out how long they were, how much I wanted to cut them, and I started drawing out my design, planning it all out. Once I had it all planned out on graph paper, I started making cuts to the popsicle sticks based on what I had marked on the paper. Another thing that was very helpful that I found out through my STEM club at school we were testing is we took the popsicle sticks and had them spaced like this, and just had plugs on either end, so there was gaps in the middle, but it was still 3 thick at some point. It was much lighter than actually having like 3 popsicle sticks side by side. I used that throughout my design on the sides and on the joists on the bottom of the bridge. That method is very helpful because I could interlock parts of my bridge. So on the sides of my bridge, once I had built them, I interlocked the parts of my roadway. So I had part of my roadway going through the side. There was a Lego thing that I had made that was the width that I wanted the bridge to be, and I put it in between the 2 pieces that were flipped upside down, clamped them against it, and then attached them very lightly. Once those had dried, I flipped the bridge over, laid the roadway on, and then once that was dry, I flipped it over again and put a zigzag on the bottom of the bridge, and then I was finished.
All right, thank you.
Hi, I'm Lil Stevens, and my bridge is...
There we go.
All right, we're ready.
All right. All right, and we're loading. 7 pounds right now. Ten. Just past 20 pounds. All right. Five. Come on.
Holding its shape pretty well.
You're a little cracking.
Starting to see some portion at the bottom.
Ooh.
All right, final load was 31.1 pounds. Yay, congratulations, Harrison Prep, for the Matthew McDonald Memorial Bridge. We will continue on with our second bridge, which is Ingram High School, the cantilevers, submitted by Megan Doyle. The bridge weight was, oh, this is supposed to be Rom's slide. I'm sorry, Rom, you take over my next one. The bridge weight is 297.7 grams with an estimated load of 21.6 pounds.
Hi, my name is Megan.
Hi, my name is Kaya.
And I'm Callie.
And we are the cantilevers.
We started out by brainstorming different bridge designs and decided to base our bridge around one arch with triangular supports.
We then made a blueprint for our bridge, making sure to follow the building codes.
Then we started to build. We started with the roadway, then we built the legs and the skeleton of the arch of both sides together to ensure that they were symmetrical. Next, we connected both sides to the roadway.
We then gave our bridge to another teammate who added final supports to make sure everything was connected properly.
Throughout the building process, we referenced the building codes frequently, and we also used rubber bands, binder clips, and books to ensure the bridge dried in the correct shape.
Finally, we performed initial tests to our bridge and then sent it in.
Awesome. it does the double repeat thing.
All right, and we're loading. £6 right now.
Nine.
Double digits, we're at 12. $15, all right.
Peers are holding well. Start to see it moving.
£20. You can see a little
25.
deflection on the bridge deck. Ooh. Now we're at 30.
See the arch holding up well, even though the deck's starting to deform.
5. Ooh. 37.
All right, final load of 37.1 pounds. Thank you, Ingram High School and the cantilevers.
So we're going to take a quick break from breaking bridges right now and start with our first guest speaker of the day, Joe Taylor. So Joe is a construction engineer who has worked throughout the country on large-scale infrastructure projects. Joe is currently working on a water treatment project here in Olympia, Washington. Today, we will hear how Joe got interested in engineering and what to expect in a career as a construction engineer. Please give a warm welcome to Joe Taylor.
Hey, good morning, everyone. Thanks for having me. Let's see here. Share my screen. So, yeah, as Romulus said, I'm going to talk about a career in construction and kind of a brief introduction of who I am and how I got into construction. So if you guys have any questions, you could just write them in the chat box and I'll try my best to answer them at the end. So who am I and why am I talking to you today? As Romulus introduced me, I'm Joe Taylor. I've worked in infrastructure projects all over the country. I'm going to talk to you about how I got into construction, kind of a brief history of my career, what I do day to day, and kind of the key takeaways that I've learned in my career so far. So here I am. This is me on the job site, my PPE. I'm a project engineer at Prospect Construction right now. I've worked for other companies, Flatiron and Kiewit. You might have heard of them before. I have a bachelor's of construction engineering from Murray State University in Kentucky. I graduated 2015, and currently I'm 30 years old. I thought it'd be kind of fun to show you what I looked like in high school, and so this is me in 2009 when I was a senior. I wasn't the best student in high school, but it's because I really didn't know what I wanted to do. And so I kind of felt my way through life, kind of figuring out what I liked and what I was good at. And in high school, I really liked geometry, and I really liked the classes where I got to kind of work with my hands and do more practical things like auto shop and woodworking, metalworking, and things like that. During the summers, I would go and help my friends build patios for their parents and stuff like that, building decks and all kinds of stuff, make a little side cash. So I started working with hand tools doing that. Then I kind of graduated up. After I graduated high school, I got into power tools, and I worked for a fabrication shop in my hometown. And from there, I even started helping my family remodel their houses. So the kind of the pictures on the right are a metal fabrication shop similar to the one I worked in. Some CAD drawings, because I was exposed to that very, way back when in my career, looking over the project manager's shoulder to see what the plan was, what's going on, and kind of a picture of a gutted house similar to what I was doing with my family. So by then I kind of realized what I was good at and what I really enjoyed. It took me a couple of years to figure that out. I didn't go to college right away after high school, but I think for me personally, that really helped. And even when I got to college, I actually had a time where I switched my major because I realized I initially had signed up for mechanical engineering. And one day the professor asked, how many of you guys want to sit in your office and design stuff all day? I had already knew that wasn't for me. So I went and switched my major to construction engineering, and I definitely know it was the right choice. But it's okay getting into things and not exactly knowing what you want to do right away. Eventually I figured it out. And here's a picture of my college down in Kentucky. And there's some Tuesday night homework, some calculations for reinforced concrete that I got to do. So here's a map of all the different places I've worked around the country, from Denver to Wisconsin, Maryland, Sacramento, and Seattle, and here in Olympia. And those are the logos of the companies that I've worked for. So I've got to work on different types of projects. The water droplet kind of represents water and wastewater projects, and the little factory logo kind of represents more industrial type projects that I got to work on. So going right into some of the projects that I got to participate in. This is the Denver wastewater treatment plant upgrade. It was about $150 million. So here's an aerial shot of it. You can see kind of on the left side, a big aeration basin being built. It's all concrete, rebar, big pumps, that sort of thing. This was a really cool project just because the sheer volume of it. It treated 220 million gallons per day and up to 340 million gallons per day in a storm event. And so I kind of did the math and figured out if you took all that water in one day and put it in bathtubs and lined them up, the bathtubs would stretch 7,600 miles, which is like from New York City to LA 2.5 times. So that was pretty impressive. One good thing about this project, personally that I felt, was the environmental stewardship. As my first project, I really felt like I was making a good impact, helping the environment and that sort of thing. So I felt good every day when I went home. Here's some shots more close up. So there's aeration basins there on the left and some big pumps on the right. Those pumps, each pump 35,000 gallons per minute. The motor right there up on the top of the picture is about 7 feet tall. And if you took one of those pumps, there's 6 of them there. If you took one, you could fill up an entire Olympic swimming pool in under 19 minutes. So just the sheer volume of this project was really fun to work on. Next, I kind of went back to a pipe fabrication shop. So it was kind of funny going back full circle, back like I had done right out of high school. This was a pipe fabrication shop that was fabricating pipe for a liquefied natural gas project. It was really cool. Again, it was a huge, massive project. Kind of my duties were tracking all the pipe and making sure that it got fabricated in the right amount of time, and making sure that it got to the project site. So there was over 10,000 individual pieces of pipe. And if you can imagine, that was pretty hard to keep track of. And so we actually tagged all the pipes with RFID tags. And we had a yard, and we had a little scanner that we can kind of ping off where the RFID tag signal was coming from, and it would help us locate it so we can get it loaded on the truck and ship it out. I thought it was a really cool use of technology. So this is the project that the pipe was actually going to. This is Cove Point Liquefied Natural Gas Export Terminal in Lusby, Maryland. You can see there just again, the sheer size of the project was really cool. It was really fun to work on. So there were 58 cranes on this project in a 54-acre site. It was very hectic, if you could imagine, making sure the cranes didn't hit one another at all times. So that was a major part of the planning that had to go into the work. It was very fun to be on. You know, you felt like an ant working in a giant forest of steel. And so there was actually 20,000 tons of steel, 5.4 million feet of electrical cable, and all those 10,000 spools of pipe actually stretched 338,000 feet, which was 64 miles. So I remember learning that if you took the pipe and stretched it all end to end, it would go from the project site in Maryland all the way to Washington, D.C., which was about 64 miles away. So it was really cool. This project consisted of 2 power plants, so it was more like projects within projects. The power plants powered compressors that cooled and compressed the gas down to negative 256 degrees Fahrenheit. That's the temperature that the gas liquefies so that they can ship it across the ocean. And all this gas actually goes to Japan to power power plants as a more clean energy to burning coal. Another aspect of this project was that it was a design build. So the design was going on at the same time we were constructing. And it was a really invaluable tool to have this design accessible to us as we were building it. Because as you can imagine, getting certain pipes into really tight places is hard to tell if it's going to work if you don't already have a model to kind of test it out on. And so we got to do that. And so here's actually a video of us getting a piece of pipe into place that we had made sure would fit using the model. So there you can see we're actually lowering it in with a crane, and the tolerances are very tight because it's surrounded by pipes on all sides, and it's a crazy shape with all the goosenecks and elbows on there. And we wouldn't have been able to do it if we hadn't had access to that model. So that was part of the fun planning of working on this project. Really valuable tool. Here's an aerial view of that project, so you can see how big it actually stretched. Offsite area A is where we all parked, and we had to get bussed in every day 2 miles. So there was about 12 big tour buses that would make trips 24/7, going back and forth, dropping workers off, bringing workers back to their cars. Offsite area B is where a lot of the material came in on barges, and then we had to put it on super heavy load trucks and bring it into the project site. And then, in fact, some of the workers actually had to work, they had to take a boat to get to their actual location when they worked out on the pier. And so that was really interesting. And I kind of put a snippet there of what an LNG ship looks like. And that's about scale. So you could fit about 2.5 of those ships there on that pier. That's how big it was. So here's some other photos that I took. I worked night shift part of the time, and we transitioned to day shift eventually, but there's some big equipment. You can see in the middle picture, a crane setting a big heat exchanger. And in the right picture is a crawler crane taking apart one of the tower cranes as the project came to a close. So my job assignments on this project were managing crews, and I can't stress enough how important the planning was and the communication, on a project this complex. So going into what I did at Flatiron, I worked on another wastewater treatment plant as I transitioned from the East Coast to the West Coast. So this is in Sacramento. It was a $2 billion project. It involved 22 individual smaller projects. And so my portion was just a small piece of that puzzle. This project was really cool because the engineer had made the entire model in virtual reality. So you could put on a headset and actually look where you were in the project and kind of go over here and go over there. And it really helped us see if everything was going to fit up right. That was very unique, but very, very helpful tool. Some of my job duties on this project involve PIC planning. So here is a picture of a PIC plan that I got to plan out. So it's taking a chemical storage tank and picking it off this truck and setting it in place. that was a really cool portion of it. And again, the planning involved is really the lion's share of what I do every day is the planning. Here's a picture of my recent past project here in Seattle. So this is Georgetown Wet Weather Treatment Station down in South Seattle. We had 25,000 cubic yards of concrete, and we excavated 23,000 cubic yards of soil. So part of this project, some of the planning that was really unique was to get all that soil out of this pump station, we used a dredge. And so this dredge actually hangs from a set of leads of the crane, and it's basically like a big vacuum. There you can see the water jets that will lower this down underwater, and it actually breaks the soil up, and the big vacuum kind of sucks it up. And then at the other end, it blasts it out of the end of the hose where we can pile it up, let it dry out, and load it on trucks. So this was about 4 times faster than doing it in a conventional manner. And so, you know, again, that's how planning can go a really long way and help keep your budget and keep your schedule. So this same structure here, the next step was to pour a big plug of concrete in the bottom. The plug of concrete was 35 feet thick, and it consisted of about 830 concrete trucks full. And we placed it all in one night. 28 hours, we placed 830 concrete trucks. So the logistics of getting the trucks in and out of the site was a major challenge, but we had been planning this for a year before we actually did it. And all that planning really paid off because this certain task went off with no injuries, and it went quicker than we had anticipated, and we actually made good money off of this project. So that was very exciting. After we placed the concrete, we pumped all the water out, and here you can see some more pick plans, like I had mentioned at the previous project, lowering some excavators and earth moving equipment down to kind of clean up all the rest of the mud and stuff that had been left behind. So that's really cool when you get to fly a 40,000 pound piece of equipment into the hole. That was a really cool aspect of it. As the work progressed, we went to pouring walls. And here's a picture of it when it's near completion. All we had left to do now was pour the lid on top. The deck was 2.5 feet thick of concrete. Here we are starting to form it up from an aerial view. And here's the false work for the lid. We actually poured this with hanging false work instead of a traditional shoring tower method, which is similar to a bridge. And here we are pouring the concrete. The guys are finishing it off, and it was a good deal to finish that off. All this was going on one half of the project, while this other structure was going on the other half of the project. So if you can imagine how important the communication was, hey, I got all this concrete pouring today, and the other side of the project had to say, okay, well, you know, we're kind of limited on what we can do because all these trucks are coming in. So communication is really important. And this is my current project that I'm working on. So we're just getting started at the at the Lot Wastewater Treatment Plant in Olympia. And we have already modeled this entire project in 3D AutoCAD. And it's already proving to be a massive help to make sure all the piping doesn't conflict with the electrical and the other equipment that is involved. And so kind of leading into my key takeaways here is find what you like to do, and hopefully you can find what you like to do, because it's very important when you're going to work every day for the next couple decades that you're fulfilled and you're happy with what you do. You got to have that passion. The most important skills in construction are communication and planning. As you see, these big complex jobs are very, it's very important to have a good plan and to be able to communicate that effectively with your teammates. And then my last takeaway is that design and construction are becoming more integral. So back when I was in college and the professor asked, who wants to design stuff all day? You know, if I had stuck it out in that role, I still could have found myself in a very similar position working for a contractor in construction. So as the design and the construction are becoming more integral, there's a lot more collaboration and communication from both sides of the aspect of construction. And so I couldn't be as effective at my job if it weren't for the designers, and I want to say thank you to them. And so that's kind of my presentation in my career in construction. So if you have any questions, please feel free to ask.
All right, thank you, Joe. We actually have one question right now. How often do you see the same people on different projects?
Oh, so as you see, I've stuck with, or I haven't stuck. I've switched around to different companies quite a bit. So in that regard, not too often, but when you stay with the same company for a long time, you end up working with those people more and more and more. And with respect to me working for a contractor and other people working for designers, you do run into the same designer quite often, even if you are with different companies. So I would say maybe 20% of the time you might actually know someone from one project to the next project. Good question.
Awesome. Joe, I had a quick question for the excavation done at Georgetown, weather treatment station. What type of shoring system did you guys use out there? Was it secant piles or?
That's right. So
piles or?
Yeah. So the whole structure was there were 96 secant pile shafts that were 4 foot diameter, drilled and concrete poured back. And that's what created the shell for us to go and dredge out all that material. And that was kind of the exoskeleton of the project.
How long did it take to excavate all that material away?
So we dredged out about 22,000 cubic yards in a month. And it's kind of funny because the dredge only had to work about 7-8 hours a day. And the people loading the trucks actually had to work 10-11 hours a day to keep up with it, and they had to work Saturday, and the dredge only had to work Monday through Friday. So the dredge was actually really effective. Our limiting factor was getting the material off the site. Yeah, great question.
Joe.
I have a question about, I guess that's a similar project, but I guess it would apply to any of your projects. In terms of going between design and construction, how often do you, when you're dictating, construction often dictates means and methods for how you do it, especially with the dredging. I'm really curious, was that like Flatirons, what they brought to the table with it? Yeah.
Yep. So that kind of the idea there was that we were limited by the specifications or the building code, similar to the limitations with the Popsicle stick bridge, that we had to excavate it in the wet. We weren't allowed to pump the water out. So it was either with traditional methods, which would have been like a clamshell bucket and a crane. And how many buckets would that have taken? It would have taken, maybe 11,000 bucket loads or something if you had a decent sized bucket. That was Flatiron's idea. So that was a construction manager came up with that idea and kind of said, hey, what about dredge? And then he kind of put it on my plate to figure out how to make that happen. And, the more research I did, found out where to get one, who we had to get it from. It actually came up from San Diego, and how to make it all work. And it really paid off. But yeah, it took a lot of effort to plan and think it through of how we were actually going to accomplish it.
Yeah, just for the students, because I know I definitely did not know this in high school, but I think that's one of the really exciting parts of our industry of doing construction work and also design of it is that kind of problem solving of there's the side of design where you have to, your client offers you a problem that they need fixed, and in this case it's designing the CSO plant, and then on the construction side it's the problem solving every single day of how are we going to do this, and doing the front load planning. And I know most people get into engineering because they like to do problem solving, and I just, this is real time stuff, and you definitely see it on the construction side like daily, and it's really fast paced. So I just find that so exciting.
Yeah, absolutely. And I can echo that for sure. The problem solving and coming in and there's no roadmap, right? You have the limitations, but there's nothing that says do it this way, and trying to figure out how you're going to do it is really exciting. So one example is on the current project, we're building a precast concrete structure, and none of us have ever done that before. We're gonna figure it out, and then that's the part of, that's the communication, the teamwork. Well, hey, I know this from this experience, and somebody else knows something from that experience, and putting it all together and coming up with a good solid plan. It's the best part of the job.
Thank you. Yeah, awesome. Do we have any other questions from students or anyone else in the audience? I know not everyone on the call is students. Well, I just want to say another plug. I had the opportunity of going to Georgetown this past week, and I climbed down into that wet weather station, and
Awesome.
Man, it is cool. One, it was really terrifying climbing down that ladder and scaffolding. So that had a little bit of vertigo there, because you climb down this tiny little shaft and onto a ladder, onto a spiral staircase of scaffold steps. So definitely, I guess not for the faint of heart. I might have been shaking a little bit, but once you're down there, you look up and you just see this marble that got put in. I think that's one of the really exciting things that I've experienced, and I'm sure you can. A lot of engineers on the call can attest to this too. But being in places that other people aren't gonna pretty much ever be in again, I think is just a really cool aspect. I know my Bobby Gilmore, our president, she took me down there, and she was saying that too. It's really exciting to be in places like that. And I do wastewater stuff as well, so I'm often in places that no one wants to ever go in, because I do a lot of sewage. But my fishing waders have never been used for fishing. I'll just leave it at that. But that's definitely an exciting spot, place to be, and something that that you've had a part in. And I know I didn't have a part in Georgetown, but it's cool to be in places that no one else will be.
Yeah, absolutely. You're probably one of 50 people that will ever be able to say, I was in there.
I know. Super cool.
All right, we got one last question here.
Yay.
Joe, you mentioned you were struggling to find what intrigued you in high school. In hindsight, what would you recommend a high schooler to do to prepare for going into a technical union?
Oh, excellent question. I can't say how happy I am enough to have this question. So getting into the technical union is a very promising way to have a very fulfilling career going forward. And oftentimes I kind of think if I would have gone that route, how would I like it, and would I be fulfilled, and that sort of thing. So to find out if you would really enjoy being in a technical union, I would say take as many courses as you can, working with your hands and problem solving. Geometry is very important in the technical unions. And the classes kind of that I took, the auto shop, the woodworking, and that sort of thing, figuring out how to do stuff. And the unions are really good about having a lot of outreach programs. And so you can call any of the unions up. You could just Google them, Google their phone number, and say, hey, I'm a high schooler. Can I come to, or can I check out one of your apprenticeship programs? And they'll send you all the information about it. And that's the cool thing about the union, is that they have a 4 or 5 year program, depending on which union to get into. And instead of going to college and paying for it, you're in an apprenticeship program and you're learning, and you go to classes after you work and they pay you. It's a really fulfilling, promising career. And there's a massive need for people that want to join the skilled labor trades right now in this country. So it's an excellent opportunity.
Awesome. Well, if anyone has any further questions later on, feel free to ask, but I just want to say thank you so much to Joe for giving his presentation about his life as a construction engineer and sharing with all of you.
Yeah, thank you for the opportunity.
Big virtual round of applause. Woo. All right, so we'll move on to a little bit more trivia before we hit the next stretch of breaking bridges. All right, so everyone get ready in the chat. What is this bridge? Let's see. Got Brooklyn. No, Manhattan. Any other? Someone just said big. Oh, I'll wait a couple more seconds. All right, so it is the Brooklyn Bridge. The Brooklyn Bridge was in construction starting in 1869 and in 1883, and it's about 6,000 feet long. Now we can speed on to the next question. So Washington is home to 3 of the longest floating bridges in the world. You'll get 1 point for each one you get correct. So we got 520, that's one of them. I-90. Okay, Hood, Evergreen, I-90. A couple more seconds here.
We're missing one. We're still missing one.
No, somebody got the Hood Canal already, so that's all of them.
Okay.
All right, so number 1, that is 520. That is the longest. Yeah, same bridge. It is 7,710 feet in length, so that is the longest floating bridge in the world. Number 2 would be I-90. That is 6,600 feet long. And last but not least, the Hood Canal Bridge is 6,500 feet long. So congratulations on all of you for getting that correct. I believe so. It's named after the governor, but I can't quite remember. All right, on to the next one here. What is the tallest building in Seattle? All right, we got 1 answer in. Got 2. I think that was just. Another 5 seconds here. Okay, so it is the Columbia Tower. That is correct. It also has a really nice observation deck out there if you want to check that out. It is 937 feet tall, and at the time of its completion in the 80s, it was the tallest structure on the West Coast, but as of 2017, it is the 4th tallest skyscraper in the West Coast. So we'll move on to breaking more bridges.
All right. Rom, since I took your slides, do you want to do
this? Sure, sure. Moving on to our next bridge from O'Day High School, the Ricard. It has a bridge weight of 299.5 grams, so right at the limit there, and they estimated a load of 27 pounds. Let's see how they did.
So my name's Andre Ricard. This is my bridge, the Ricard. When I was building the bridge, I started out with a lot smaller triangles, but because of that, the angle would have been a lot taller, and I had to restart. And so I went with a wider triangle so that the base and the structure was shorter. And I went with a simpler style so that I could afford less weight but still have some strength. That's why I kept the triangles. And yeah, my dad, he's an architect, and so he helped me out a little bit with some of the structural stuff. He suggested I add these so that it doesn't split in the middle. Yeah, that's it.
All right, and let's get to loading the bridge.
All right, coming down.
About 6 pounds right now. $12. See a slight bow in the deck at this point, but still holding pretty strong. Up at 21. $30.
Ooh.
Wow, you couldn't even see that it was deforming until it lifted. That was good. All right.
Final load, 41.6 pounds. Congratulations.
Jabo day.
So going on to bridge number 4 from Ingram High School, double ACE. They had a bridge weight of about 289.2 grams, and they estimated a load of 100 pounds. Let's get to know more about the double ACE bridge.
Hi, my name is Carolyn and I'm in 12th grade.
Hi, my name is Estella and I'm in 11th grade.
Hi, my name is Austin. I'm in 11th grade.
My name is Akash and I'm in 10th grade.
We're from Ingram High School.
And we're Team Double Ace.
And the double A stands for Akash and Alston, and the CE stands for Carolyn and Stella. And we started with looking at the building code, and we noticed that the maximum weight was 300 grams. And so to get the slimmest design while remaining under that weight, we decided to go for a more triangular design.
And I used this design to guide me through building the one side of the bridge that I made.
Create a more accurate duplicate sideway model. I create a template and then put the sticks on.
I then glued both sides of the bridge to the roadway that I'd built and added extra layers for support.
So with our design, we decided to go for more of a poker aesthetic, because the acronym that we developed reminded us of dealing with cards.
Right now I'm building a bridge sideway, and we're doing a triangle but not connected to each other to provide support to the bridge.
I just picked up the sides of the bridge from my teammates, so once my roadway is done drying, I will stick the sides on.
All right, let's load up the bridge.
Already coming in about 9 pounds. Loaded really quickly, so. $20. $30.
All right, we're picking up load pretty fast now.
$40. Yeah, we are. $60. 80. Keep going.
No observable deflection yet. Looking good. 100.
Starting to see the deck a little bit, but barely. Ooh. 120. That one is interesting. You saw it kind of have some torsion to the side. Awesome.
So double ace, you got a final load of 139 pounds. Congratulations.
Nice job. Nicely done. All right, so now we're gonna hear from another guest speaker, which is the University of Washington's Concrete Canoe team. And I will let them explain what that is.
Okay.
Oops, sorry.
Okay, I'm just going to share my screen.
There you go.
Okay, hopefully you guys can all see the screen, but yeah. Neil, if you can get started.
For sure. Hey, everybody. Real quick before we get going, we're just going to introduce ourselves for you. So my name's Neil. I am currently a senior studying civil engineering at the University of Washington. And within that, I'm looking to focus in roadway design. So I'm originally from Charlotte, North Carolina. I'm currently the outreach lead and co-captain here at University of Washington, along with Shuki. And a fun fact is I play on the club volleyball team.
And hello, everyone. My name is Shuki, and I'm currently a junior in civil engineering. And like Neil said, I'm also one of the captains, as well as one of the concrete mix design leads. A little bit about me is I was born in Hong Kong, but I was raised in the greater Seattle area. And some of my hobbies include just like making and building things. So includes cooking, knitting, sewing, things like that. And I've also included some pictures, some similar projects that I worked on in the spirit of the competition. To the right, this one's made out of balsa wood. And to the left, this one is just like a simple truss that was 3D printed.
So before we get into all the fun stuff about concrete canoe, there's a lot of great science that goes into how our canoe actually floats. So if y'all just want to throw in the chat real quick, why do you think things float? Obviously, we have some stuff that floats over here and some stuff that sinks over here. So if you want to unmute or even just throw it in the chat, just why do you think things float? Why do they sink? Yes, the classic answer. Yep. All right. Definitely, definitely some important answers in there. So right here, this is the idea of buoyancy, and we just wanted to introduce this to you real quick. But on the left side, so you notice that the weight of an object is typically counteracted by something called a buoyant force. So a buoyant force goes underneath when a body of water acts on a force and typically tries to counteract the weight. So you can see on the left side, when the buoyant force is greater, it'll float. The buoyant force is less, it'll sink. So based on that, how can we get heavy objects to float? So as long as we can make that buoyant force greater than the weight of the object in question, we should be able to make the object float. So you can see, a giant cruise ship here. That's how you get it to float, based on what type of, how much weight you can essentially counteract with the buoyant force and how you build it intelligently. So obviously, whenever you make industry concrete, and I'm sure Joe could tell you a lot more about it than we could, but it's typically got a strength of about 4,000 psi. And you can guess with concrete being that strong, it's going to be really, really heavy. So that doesn't make sense to build a concrete canoe with, because it's going to sink, right? The whole goal of our organization is we want to get our canoe to float so we can eventually race it and present it and compete with it. So what can we do as a team to make the concrete float? So I know we touched on it a little bit earlier, but essentially our goal within canoe is to get our concrete less dense than water. So water has a density of 62.4 pounds per cubic feet. So we have a theoretical density up top that we calculated in our last submittal this year. But after we add our air content, so we add voids of air in a lighter weight concrete, we can get it less dense than water. And once it's less dense than water, it'll flow. So that's where a lot of the cool science behind it comes. So a lot of it does come down to that density and that weight just being less than water, so that the buoyant force of water can keep it float. So that's the science as to how our canoe works. I'm going to go ahead and pass it over to Shuki, and she'll tell you a little bit more about concrete and what our team does.
Yep, so before we talk about the team, just wanted to kind of expand on concrete as a construction material. So as you guys know, earlier on in the first trivia, concrete is one of the most commonly used construction material. And the reason, I guess a little bit more about concrete is that it's categorized as a composite material, and this just means that it is composed of other materials, including aggregates, which are at its core gravel and sand, as well as cement and water. And when cement and water are mixed together, they chemically react to form a crystalline structure that hardens over time. And this also acts as a binding agent that holds all these aggregates together. And the aggregates serve as both a filler material as well as a strengthening component of the concrete. And the reason why concrete is one of the most widely used construction material is because of its versatility. So you can use it to build buildings or floating bridges, or they're just like residential buildings, as well as like sidewalks, railways, and like things like that. And it's also really strong, durable, and very low maintenance. And for us, one of the main advantages of concrete is that you can mold it into any shape. So when it's freshly mixed, you can shape the concrete into any shape you want, and once it hardens, it just holds that shape. And besides, and I also just want to highlight some other applications that I find very interesting with concrete is that you can use recycled aggregates. So on the left, you can, in the city of Bellingham, Washington, they actually crushed up old toilets as well as old construction waste into smaller pieces so that they can incorporate that into their concrete for their sidewalk. And this just helps with the sustainability aspect of concrete because when the production of cement isn't necessarily sustainable, so by using old construction waste, this helps kind of mediate some of that. And another interesting use is self-healing concrete, and it basically there is one method where we incorporate bacteria in concrete so that it self-heals, kind of like minor cracks in concrete. And then another interesting application is pervious concrete, and it kind of looks like Rice Krispies in a way, but it has like a lot of pores where water can drain through, so it helps with like stormwater management. And for us, our application of concrete is using lightweight concrete in our canoe. So what that means is that the aggregates we use are much smaller and much lighter, so they're less dense, and that just ultimately helps make our concrete float. And each year we build a concrete canoe from scratch so that we can compete it in a similar competition as you guys are in right now. And for us, our competition traditionally is composed of 4 parts. We have both a technical paper that we write up as well as a presentation. And then we are also judged on our final product, which is our canoe. And we also actually race in our canoes once we're done with them. And kind of similar to a lot of the videos that are shown today, our typical process throughout the year is doing a lot of research and design in like autumn, winter, and then we build our canoe. And then in the spring, we take it to competition and compete with other schools. In terms of research, we gather a lot of information from previous years and look at how previous canoes have fared in competition. And we also look at old papers, other schools' designs, and things like that. And during our design process, we do a lot of testing and design. So like for concrete, we mix several batches of concrete and see how that tests like the strength properties and things like that. And we also also test other construction techniques, and also we use other modeling software as well as structural analysis and calculations during our design and testing process as well.
Yeah, so
And Neil,
yeah, after we get through that design process, essentially we're trying to figure out the best way to build the canoe in terms of what we've got with the strength of our concrete. That's really important. Don't need any canoes breaking on us. That's not good. The means and method by how we're going to go about that, though, is part of the construction process. So we're going to finalize any techniques, and we're actually going to place the concrete. So if you can see on this left side of the screen here, these little black areas, that's all concrete, and we've put all of that down by hand. Along with that, in this picture in particular, since concrete is very strong in compressive strength but not very good in tensile strength or flexural strength, we put in types of reinforcement to make up for that lack of strength there, as you can see on the screen. So the build process is essentially a lot of time just figuring out, okay, now we have all this design work. What's the best way to do this? And that's very similar to what you'll see in the industry as well. So finally, we've done all the hard work, right? We have researched what we want to do. We have designed our product, we built it, and now's the fun part. We get to go to the regional and national competition and show all the work we've put in. So I know Shuki mentioned it a little bit earlier with like how everything was broken down, but this is typically 25% of our score. And typically, as you can see, they do actually get out and race it. Obviously, can't do that this year with COVID, but along with that, we do also a presentation about everything we've done the entire year, and it's just a lot of fun altogether. It's definitely the highlight for a lot of people. Here are just some different pictures of the team throughout different phases within the process. In the top right corner, you can see that they're mixing some concrete in a bucket, which is super, super cool. And along with that, it's just a very collaborative experience, a lot of great opportunities, and have met a lot of super cool people through the club, with a lot of them being civil engineers. So for sure, definitely an awesome opportunity to not only get more involved, you know, when you get to college and learn more, but the people that you spend your time with in this club are going to be, you know, industry professionals in 5-10 years. And those connections really do mean a lot. So I know I've really enjoyed my time, and I will continue to. And it's definitely been an awesome part of my college experience. Thank you so much for your time, everybody. I know we kind of just threw a ton of information at you. Hopefully some of it stuck, or you at least thought it was cool. If you want to, go ahead and put something you learned in the chat, or feel free to drop us any questions, and Shuki and I would be more than happy to answer.
Awesome. Thank you all. So if you have any questions, feel free to put them in the chat. I had a couple questions for all of you. I guess probably most relevant to the high school students. What was your experience like in getting to engineering school, and what is like being an engineering student at the university level?
Yeah, I guess I can take this one. In terms of getting into engineering school, I didn't really have that much experience before, so I did some community college classes, but that was pretty much it. Getting to UW and my experience with engineering, I already kind of knew what I wanted to do within civil, so I didn't need to do a ton of exploration or other majors, but it's definitely a lot of work that goes into it. You really have to be someone who enjoys that technical aspect of it. But all the stuff that you do in high school, like all the clubs, really do start building that experience for you, even if you don't realize it. Like, so much of engineering comes down to communication, teamwork, building relationships is really, really important. And a lot of people, you don't think about that, because when you're in the field working in construction, you know, you're working with your crew. When you're in the office doing design work, you're working with your team. So I think definitely based on what aspect of engineering you go into, you know, there is work, but it is really enjoyable if you find the right spot for it for you. And within civil, we have, I believe it's 6 or 7 different subsets here at UW within different opportunities in the major. So you're never going to be stuck, for sure. There's always different opportunities to change careers and grow. So as long as you're willing to work, I think it's a great opportunity. That being said, you know, you do have to make sure, okay, I'm ready for this challenge. This is something I'm looking forward to. And there's a lot of opportunities there. So I've had a pretty positive experience. I absolutely love the civil department here. They're great.
Cool. Thanks, Neil.
And I guess I can also talk a little bit about my experience. So I guess like in high school and senior year, I still didn't really know what I wanted to do. I just knew I wanted to do something in STEM. So a lot of the classes I took to prepare for, I guess, university is just a lot of STEM-based classes, but not until I was participated in this program called ACE. I don't know, so you guys know, but it's a high school program for high schoolers to learn more about architecture, construction, and engineering and the field involved. And that's when I knew, I was like, civil engineering is very interesting, very fun, but there's definitely a lot of subsets within civil engineering. So that's why coming to university, I wanted to join a engineering club so I could like learn more about the industry, about the field. And I guess through this process, I got to meet a lot of great people and got to kind of just learn a lot. University is all about like the learning experience, so you don't need to know anything going into like any clubs or anything, as long as you're willing to learn. Yeah.
Got a question here. What are the subset / disciplines in the UW's civil engineering program?
I guess someone can like add in if I forget any, but there's hydrology, structural engineering, geotechnical engineering, environmental engineering, there's construction engineering. I think I'm missing one.
Transportation would be another
Transportation
one.
engineering, yeah. Yeah, and then Jake has them all typed out.
I guess I had a question for canoe stuff. How many mixed designs did you guys go through before you found the right one? And then just for the student, can you explain a little bit more about that process of creating cylinders and just kind of the iterative method that goes into it?
Yeah, for sure. I guess I can speak to it as the mixed design lead. Definitely this year is very different from our testing and design process, definitely different from other years. But traditionally in the autumn, we do a lot of research and testing, and that involves kind of ordering materials and then batching them, weighing them out, and then I guess mixing them all together and then creating samples. And this includes like 2x2 cubes, as well as like 6-inch diameter cylinders that are like 12-inch high. And those sizes are like standard. They're standards for tests that we conduct. So once we make those samples, we let it cure. That just means that the concrete hardens and sets and strengthens. And once it cures for a certain amount of time, we get to crush them using some of our machines in our lab. And similar to the ones you saw in the videos, and then you can find the failure load, and then you can determine the strength of our concrete. And it's just a very like repetitive, iterative process that we like do once we figure out like how like a certain design fair, and then we just repeat that process. And that's kind of what we normally do in the lab. But definitely this year is much different since we don't have access due to COVID.
Thanks.
All right, any last minute questions for our awesome presenters from the University of Washington? Cool, well, looks like
go back
good for now. Yeah.
I've got a question.
Oh, Joe.
This is Joe. So you guys use air and trained concrete. What is the % air of your mix design? What do you aim for?
Okay. I don't remember exactly the exact percentage of our air content this year, but we don't really aim for a specific air content. We just kind of like
as much as you can.
It's different for us. Yeah, it's kind of like as much as we can, and like as long as it floats and it's strong enough. And we work a lot with our structural leads to have them determine like how strong our concrete needs to be, and and then we like calculate densities and things like that just to ensure that it floats.
Okay. And one more question. What kind of lightweight aggregate do you use? Do you guys go for like vermiculite or some sort of igneous rock that has gas pockets trapped in it from volcanoes, or what kind of rock do you guys go with?
Like the type we choose each year depends on the rules as well as kind of the innovations we want to pursue. But some examples of lightweight aggregates include something called Utilite, which is like expanded shale. There's also pumice, which is like some of those igneous rocks that you were mentioning. We also use something called Porver, which are kind of expanded glass like cenospheres. They're really strong and very lightweight. And we also use like things like perlite. I think people use that for gardening.
Yeah.
We use that for testing as well. And some of the more interesting aggregates we use are like K15 glass bubbles. They're really tiny, very lightweight, and it's very fun to use. Another interesting aggregate that we used in the past are also like foam beads, and they're just really tiny, very lightweight. Although they're not super strong, but it helps with like the weight of the concrete. So those are just some examples of some lightweight aggregates that we've used.
Awesome. Very interesting. Thank you.
Just to plug, that is the difference between cement and concrete. I know sometimes when you're just speaking, people use it in the same term, but there's the cementitious materials and then there's the concrete, which also has the cement and your aggregates and water. So it's like baking a cake. It's fun. I love canoe.
It is. That's like the analogy I always use. Making concrete is very similar to baking.
It is.
Weigh out all your ingredients, mix it all together, and the baking part is just letting the concrete cure.
I did canoe in school too. And I just have to, reiterate the plug that they kind of made about getting involved in clubs and professional orgs while you're in school. I know not all the students in high school right now are going for civil, but no matter what type of engineering or STEM or whatever your field is, joining those clubs and stuff like the Concrete Canoe is such an amazing way to get connected and start your career and start your networking pool. I just can't talk enough about how networking is so influential in where you go in your career. I joined the canoe team as a student. It got me into ASCE. I literally have ASCE to thank for every single job and internship I've ever had in my career. Most of my friends are from ASCE and canoe. I met my husband from ASCE. It's just the networking that you make. I lived in Arizona the last, my entire life, and I needed to move up here, and I got a job because of ASCE and the network I made. So just making those connections, start early, join clubs in school. They will help you so much more than you know, aside from just personal development, but just networking too. So can't plug that enough. Join clubs when you're in school. All right, I'm going to click slide if my mouse comes back. All right, so we're actually going to jump into a little break. I know we've had you guys on the phone for a little over an hour and a half right now, so we'll let people step away, maybe take a bathroom break, grab some water. We'll be back in about 10 minutes to finish our bridge crushing. And yeah, so thanks everybody for joining so far. We'll start up again at 10:45. All right, it is 10:45. Hopefully people are coming back. Oops. One thing. Romulus, are you back yet?
I am.
All right. Okay, well, we're going to kick it off with some trivia, just in case we also have some people trickling in. So, second round of trivia. How tall is this, or not second round, third round or something like that. How tall is this building? And as a hint, it is the tallest building in the world. We're not going to give you a name in case you're going to look up. No, if I can. Oh, good. All right, we do have the right answer. No, we don't. We have the name of it.
Let's see. No, definitely. Just to help it scale more than. Oh, they're in meters. Man, that's close. Let's see. How about put it into feet? I'm not gonna guess. Yes, that's correct. Anybody know where this is located at?
Somewhere that uses meters.
Dubai, that's correct. 4,000 feet, that's a little too much. I mean, I'll give it. It's between. You can go between 2,000 and 4,000 feet is where we're looking scale-wise. You've been with like 1,000 feet. Oh, 32.
Getting
80,
closer.
12,000 feet. Nope, that's for airplanes. That's too much.
I don't think we're
3,000?
gonna get it nailed on the head. I think we give it to the person who got the closest.
I think right there, about someone said 3,000 feet. Oh, 2,700 feet. Oh, actually,
Kelvin got pretty close.
You know, Adam has 2,700 feet, and that's just 22 feet off, and I think that's pretty good, unless I missed someone.
Oh, I was looking at this. Yeah, so I think we go with that. All right, so the Burj Khalifa is constructed. It was built during 2004 to 2009. It is 163 stories tall, 33,330,000 square feet, and it is 2,722 feet tall, which is really tall. All right, next question. There's a famous engineering failure in Washington that led to the construction of the new bridge, which is the Tacoma Narrows Bridge. Does anyone? I'm not sure what your question was here, Ram, but what the name of the original bridge?
I remember. What year did the first Tacoma Narrows Bridge go down?
Okay. You may remember this from high school physics class. I know my high school physics class showed the video of it.
Okay, let's see, too recent and too old. So someone between 1890 and 1976.
They called it Galloping Gertie as another hint.
Oh, there we go. Oh, wow, average. Let's see, 1948, 50, 24, 1940. There we go. 1940 is what we're looking for.
Galloping Gertie happened on November 7th, 1940, about 4 months after it was open to the public. Which is pretty sad after 4 months. Rom, would you wanting me to click on this link?
No, that was
okay.
Good. It's okay. Everybody knows that one.
Okay. All right. What city is the original London Bridge currently located in? I may give points for that answer.
That's somewhere in Arizona. You're on the right track. That's pretty good.
So the London Bridge was an 1,000-foot span bridge that stood for over 130 years. It survived World War II's London Blitz, but it was no match for modern traffic, and it started to sink into the River Thames at a rate of 1 inch every 8 years, which is pretty significant. So what they decided to do was that they realized instead of just demoing it, they could sell it. And they went to New York and advertised it to be a wonderful London attribute, and it was bought. Ooh, someone got it right. Yep. Lake Havasu City. It was bought by someone who was trying to promote the growth of Lake Havasu City in Arizona. The final price was $2,460,000, which is absolutely insane to think of demoing and moving a bridge across the Atlantic Ocean and building it in Arizona for that cost. But yeah, so the publicity spiel ended up working. The town blossomed from just a couple hundred people to over 10,000 residents in just a matter of years. And the Chamber of Commerce reports that the bridge draws nearly 2 million visitors every year. So pretty great. It worked, but it's crazy they moved a bridge. All right, so we're gonna get back into bridge crushing. All right, so we are at bridge number 5 for Shorewood High School, the New Journey. The bridge weighed 299 grams, and estimated load that it can handle is 2,200 pounds. I'm really messing up my numbers right now. Apologies. I want to make sure I'm still sharing my sound. Good. Okay. All right.
Hello, and my name is Jenny.
My name is Catalina.
And I'm Ellie. We're seniors from Shorewood High School. Our team has entered this competition for many years, but since we are graduating seniors this year, this will be our last one. So we named our bridge the New Journey because this bridge symbolizes the end of our high school experience and the starting of a new one. In the drawing, you can see a girl standing on top of a ladder and looking to a new world ahead. Our time together as friends and as teammates was a ladder riddled with challenges and hardships. But through effort and dedication, we were able to persevere, grow, and embark on a new journey towards our dreams.
When designing our bridge, we had decided on using 60-degree triangles as they worked best in equally distributing weight. In previous years, we had designed X's for our trusses. However, with the change in weight requirement, we decided triangles would work better as they accounted for less weight. In order to get the 60-degree angle, we used the 30-60-90 triangle ruler to get the 60 degrees between each popsicle stick. To reinforce these trusses, we added some popsicle sticks on the sides. We staggered 2 layers of popsicle sticks in order to strengthen the sides. To do this, we marked the middle of the sticks, then glued the popsicle sticks so the end of one stick met the middle of another, thus making sure it was even. For the legs, we decided to create rectangles in order to create stability. We then added additional sticks in a diagonal line to reinforce this structure. Thank you for listening.
Hello, and my name is Jenny.
All right, let's get to loading the bridge.
10
10
pounds.
right now. Yeah.
It's like camber.
We got 30. Oh, picking up load. 40.
50.
50. All right.
70.
All right, make it to 100. Whoa.
Right, the final load for Sherwood High School was 90.3 pounds. Congratulations, guys.
Amazing design on the bridge deck as well.
And it didn't get broken that much, so the design is still intact.
So let's go into the sixth bridge of the day from Ingram High School, the Ides of March. They have a estimated bridge weight of about 374.5 grams, so a little bit over the 300 grams. And they put an estimated load of about 80 pounds. Let's learn more about the Ides of March.
Hello, we are the Ides of March. I'm Nikhil.
I'm Daniel.
I'm Marcus.
And I'm Josh.
So my role for the project was to construct the arches. The three major challenges that we had were keeping both arches identical, keeping them within the required dimensions, and keeping them within the weight limits. The main way that we managed to do this was by using metal clamps to secure the popsicle sticks in place while they dried, and using side supports between the two arches.
My job was to construct the main roadway, and I did this just by laying popsicle sticks down and then laying three major beams under the bottom. And while it was drying, we placed weights on top to ensure contact and maximum strength. And one other thing we did was try to space the popsicle sticks apart just a little bit to reduce weight.
My role was assembling the final product. I added trusses on the side to distribute the weight between the bridge, and I added feet on the bottom to balance and level the bridge.
My role for the bridge was I created the side supports. Last year, we also competed with the arch bridge. However, this year we hope to improve upon our design by we added more secure supports and trusses in hopes to make our bridge stronger and support more weight.
Okay, go for it. Okay, over there. Where are we at so far?
34.8 pounds.
Okay.
£12 right now. $20.
Almost to 40 pounds.
I knew you had more in you.
Bit of deflection on the bridge deck there.
It's a little bit difficult for me to hang out of here.
It's like the
Probably hold on until 100.
I don't know if I'm going to make it that far.
They're just trying to keep the piers on the pedestal so that you get the true failure point.
Yeah, it's like the foundations were translating a bit. Ooh, 90 pounds. 100 pounds. Ooh. Ooh, major.
Got one today.
Ooh.
978.
So you guys got a final load of 97.8 pounds. Congratulations.
Congratulations, guys. All right, we are on to our next bridge, bridge number 7, Shoreline Christian School. And this is Aaron. Aaron weighs 298.8 grams and it can hold an estimated load of 30 pounds. Let's see how well Aaron did.
I'm Geneva.
I'm Linnea. I'm Ione. I'm Gian.
And this is Aaron.
As soon as we heard about the bridge competition, we started to plan out what our bridge would look like. We came up with a lot of ideas, but eventually settled on one. Here's our original sketch of what would eventually become Aaron. The next day, we began to build our roadway. We went for a simple design in hopes of limiting the weight. Once we finished the roadway, it was time to begin the side paneling. We also planned to make 2 big arches for extra support, but it didn't work out quite as we planned. Once the sides dried, we made them completely level and began to construct the bridge. Everything was going well, but then we realized that our bridge was far past the weight limit for competition. We ended up having to take off a lot of our extra supports, but we were able to keep all of the foundation intact. Once we finished cutting everything up, we weighed it again and found that it was under the weight limit. Thus, Aaron was born.
All right, let's start loading the bridge. We have a shout out in the chat to Aaron. All right, just past 12 pounds.
$20
pounds. All right.
£30. Start hearing something, but don't see any deflection yet. I guess maybe a little.
A little bit. Whoa!
Torsion there at the end. Right, Aaron's final load was 49.5 pounds. Congratulations, guys. All right, so we're gonna cruise into some final trivia.
All right. So who recognizes what this ancient structure is? Roman, all right. That's the right track. Let's see, Roman waterway. Aqueduct.
Got it.
I mean, they're both kind of the same thing.
No, you got it. It's a Roman aqueduct.
I do love their arches. They're a really good way to distribute weight. So, so yes, this is the Roman aqueducts. This was built quite a couple centuries ago, and it took about 500 years to build. It was a way to transport fresh water into the very populated main cities that they had. So a great feat of engineering.
All of the aqueducts were built over 500 years, not this taking 500 years.
All right, so like I mentioned before, This is the Empire State Building. How many months did it take to construct and then until opening? So from the start of construction to opening the building in months. $30 months. 28 months. Ooh, 13 months, close. Oh man, 14, or you getting closer. 15.
Just guess.
It's okay. So, oh, there we
Throw
go.
numbers
18
in.
months. There we go. I was about to say it's less than 20. Yes. 18 months from start to finish to opening. And it has about 102 stories. I've been to this twice, and it's pretty awesome up there on the observation deck. Construction began in 1930, more or less the start of the Great Depression. And if you guys did not know, fun fact, the spire at the very top was originally used to park your blimps way back when they flew dirigibles around the world, and they stopped doing that. So, yes. And I believe onto our last trivia. Oh, okay.
Is there one missing?
That's okay.
That's why I was saying I might need to stop and start.
It's okay. All right, on to company entries. So we have 2 entries this year from Kennedy Jenks and Muller Hull. But before we break these bridges, Casey had a quick presentation on his bridge as well as the ACE program. Casey, if you would like to unmute and share your presentation real quick.
Hello, everyone.
All right, Casey.
Did I share the wrong screen? I shared the wrong screen?
Nope, that looks
There we go.
correct.
That better?
Oh, nope, that's the wrong screen now. First one was, yeah, there we go.
Oh, my Zoom went off. Whoa. Okay. So I'm Casey Risky. I'm an architect at Miller Hall Partnership, and I'm also an ACE lead mentor. And I want to plug ACE, the ACE mentor program a little bit. It is a national program that mentors high school students about architecture, construction, and engineering. And it's a year-long program that lasts about between 20 and 30 sessions over the course between November and May. And what we do is we learn about the professions, and then we actually go ahead and design a project. It's really a great opportunity to learn about all the different professions that we've been talking about today, and gain a good insight to what may be a good college path for you in the future. We also offer scholarships. Over the last 3 years, we've offered over $100,000 worth of scholarships each year. So that's a great benefit. It is a national program, so there is also a national level scholarship associated with it. And we are, this year has been totally virtual, so we will be able to reach out beyond the normal Seattle area where we usually meet in person, but we will be able to reach more virtually. So I think all classes now will have some sort of virtual element associated with them. So if you are beyond the normal commuting range, I still encourage you to join ACE. I put a plug for it in the chat earlier. It's acementor.org. And I did enter a bridge this year. My students didn't come through for me. I was hoping they would, but they didn't. So I entered one like I did last year, and I kind of walked through my bridge a little bit here. So basically I worked to the work points of where the loads were gonna be. And so I could go full presentation here. And then I used a program that's at the Johns Hopkins University, where you can actually lay out your sticks and put loads associated with those. So this is a very simple structural loading and you can understand where the compression and where the tension is going to be on those sticks. It's a free link. It's very easy to use, and it's a great way for me to understand which sticks were going to be in compression, which sticks were going to be in tension, and where the high points were going to be. So I really focused on the connection points and trying to make the connection points as strong as possible. Here you can see some of my sketches. I worked to those load points that we knew that were going to be the high points to work to. And then you can kind of see where I added additional sticks to give a better understanding of reinforcing those high point connections to transfer those loads back down to the verticals. You'll also notice that I have a lot of lateral. We saw one of those bridges kind of go sideways a little bit. So we want to make sure that we get a lateral connection to that. So that's kind of my bridge. I'm hoping to get maybe 150 pounds, hopefully, maybe a little more. We'll see. Thanks for listening.
Awesome. Thanks, Casey, for sharing.
Back.
We'll move on to break into company entries.
I did not put a presentation together for Kennedy Jakes. But thank you, Casey. Now my screen share is loading. Ram, I did restart the presentation and we do have that extra trivia slide. Would you like me to load it up? Or just go straight to the bridging?
Yeah, we can do quick trivia.
Okay. I'm going to share the right screen. All right, I think it's shared.
Quick trivia before we get to breaking the company bridges. What famous structure is this? Man, you guys type really quickly. Leaning Tower Pisa, that is correct. And fun fact, the Leaning Tower is not further leaning anymore. Through geotechnical engineering, it has been actually pushed up a little bit and stabilized. So it's going to be at a certain degrees for a couple more 100 years. Awesome. Great job on that, guys. All right, on to breaking the company bridges.
Sorry, my screen share went away. Okay, there we go. So first bridge is going to be Kennedy Jenks. Keep in mind we are water engineers, not structural or architectural, but we had fun making it anyway. Our structural engineer did also enter it into a program on his computer, so I didn't have a whole presentation for it, but he did design it on the computer first before we built it. I think more of our errors came from the constructability versus the design.
All right, we're at 30 pounds, so that's looking good. 40?
50.
That's past 50. Halfway to 100. All right.
Let's go, KJ. I'm allowed to be biased. 90.
Will they make 100?
Yes. 120. Ooh, lost a little bit there.
30.
See the deck deforming a little bit.
Oh, saw 130 there for a split second.
There we go, 130. Woo. Right.
All right, and on to Miller Hull.
Now it's the same video.
Oh,
there we go. Now Miller.
There we go. All right, chat. How much do you think this bridge will hold? We had about 130 in the last one. All right, so seating load about 10. Now we're loading up.
$20. 50.
50, halfway to 100. Looking good. And the load is really picking up
up
pretty
now.
quickly. Woo!
Ooh, we just
30.
hit past KJ.
150.
Zooming, 60.
Chat, do you guys have any other guesses what you think it's going to break at? Past 200. Whoa.
There we go.
All right, we got the final loads coming up.
Oops, sorry. Someone for all forgot to unmute that one. So Kennedy Jenks came out to an ultimate load of 139 pounds. We were way overweight with 415.5 grams. We did not have a scale. So our efficiency came out to 151. So efficiency-wise, it was still kind of okay, but we were out of the spec. Miller Hull was at a load of 218 pounds. And their bridge was 317.7, so also a little over the spec, but not quite as far. Their efficiency was 311.25, which is awesome. So thank you both to both of our corporate teams. All right, so now we're gonna hand it over to Lisa to do our winners, give out some awards.
Awesome. So yeah, we have a lot of different categories as mentioned in the rules. So the first category is the video competition. So this was new this year. We actually had a tie for the first place, and that was the New Journey and Double Ace. So congratulations. We have $25 DoorDash gift cards for you guys, and I'll mention this again later, but we're gonna do prize distribution with our final email, which will come out after the competition. So we'll coordinate that with your teachers. But yeah, congratulations. The next category is the most accurate estimate. So this is the top one team, and that was the Ides of March. So great job, you guys. This one, we have some cool waterproof Bluetooth speakers for you guys. So we'll drop those off to you. So they had an estimate of 80 pounds and their actual is 97.8. So they were very close. And then our next category is the most efficient bridges. So for these ones, we have top three. Oh, go ahead. So okay. Third place is Ides of March again. So we have some lower Amazon gift cards for third and second place. And then for first place, we have something a little bit bigger. So second place was the New Journey with an efficiency ratio of 136.99. And then in first place, we had Double Ace with 218.01. And even taking the company bridges into account, you guys were second place. So you guys were, first was Miller Hull, but you guys were second. So you guys beat Kennedy Jenks. So good job beating the corporate team. For that, we have, for most efficient, we have 3D printing pens for you guys as first place prize. Our next category is most aesthetically pleasing. So in third place, we have the Ricard, Andre from O'Day, so great job. And then second place, we have the Matthew McDonald Memorial Bridge. So Lola, great job. Very straight bridge. And then first place was the New Journey because of, when I first saw it, I thought it was printed. I was shocked that it was hand drawn. So for first place, we also have the 3D printing pens for you guys, so you can make more creations. And then our next category is strongest bridge. In third place, we have the New Journey. Their final load was 90.3 pounds. In second place, we have Ides of March, and they had 97.8 pounds. And then first place is Double Ace, 139 pounds. Great job. And then for that one, we have the Bluetooth waterproof speakers for you guys. And then our next category is the Teamwork Award. So this one we gave it to Aaron, just because we could see you guys interact in your video, and we saw that even though you guys made it and then you weighed it and it was over the 300 grams, and we saw you like chisel things off, and so we thought that was like super great work from you guys, like going back and like trying to get it under 300 grams. So for you guys, we have some gift cards. And then next we have the overall winner. So number 3 is the Matthew McDonald Memorial Bridge. Great job, Lola. We have a 10-ounce Yeti tumbler and then a $15 Starbucks gift card for you. And then also one of these little, I guess I can't show it, but we have little metal earth, like create your own little bridge as well. And then second place, we have double A's. So for you guys, we have 20-ounce Yeti tumblers as well as a $15 Amazon gift card and another one of those bridges. And then first place, drum roll, we have the New Journey. And so for you guys, we have Google Home Minis, little speakers, and then we also have a $40 gift card and then one of those buildable bridges as well. So great job, you guys. Everyone did like really good this year, and even though it was the pandemic, we really appreciate you guys working hard, and we really love the videos, so maybe we'll incorporate that next year, even if it's not virtual. Thanks, you guys.
Awesome.
Oh, and we also have a t-shirt competition. So we only had one entry this year, but it's a very cute entry. So we're happy to announce that next year's design will be from the New Journey. It is this tiger for Year of the Tiger. And so get excited for the 27th annual Popsicle Stick Bridge. And as I mentioned, we'll distribute it and coordinate with your teachers to try to get those out to you guys.
And so we just wanted to say thank you again to our generous sponsors. We could not put on this event or other events that we host throughout the year without your continued support. So it is just so greatly appreciated. We, are always excited to do these events, and especially these kind of events where we have the opportunity to submit our own bridges and work with them. And always working with Seattle Public Utilities every year has been awesome. Those guys are great, and just make it, it's so nice that they're willing to participate with us every year, and they just make this event awesome. So thank you very much. And just to conclude, I want to thank all of our participants too. So we're really excited for next year. This year, obviously, it was a little different of a year, but we really appreciate the effort you guys put in, the hard work. Like Lisa just said, the videos were an awesome addition to how we do this, to really get insight into your teams. It was great to see all your faces and get to watch the process happen and then watch the bridges. So we really appreciate it. Thanks for coming out. I'm happy you guys got to win all some prizes, and yeah, I think that's about it. If you have other questions about what we do as civil engineers, please check out our website. You can enter questions to us at #AskAnEngineer. If you'd like us to do a presentation at your school or anything like that, please let us know. We love doing outreach programs like that, and even in this virtual realm, sometimes it's almost easier to connect this way because we can share photos and cool presentations like what Joe did earlier and talk about our projects. So we hope to see you back in person in 2022 at the Museum of Flight again. Once we have more information on that, we'll follow up with you all. And congratulations to all the teams. Good luck for those of you entering college next year, or if you're taking time off, or just congratulations on getting through high school. It's exciting time for everyone, and we're just excited to see where your guys' careers go. So enjoy your weekend. Thank you so much. And yeah, virtual round of applause for all the team.